Hello, Algebra 2 students. This is a help video for the 9.02 stats project, and you're going to use some information from your 9.01. So I'll be referring to what I used in 9.01 for my data, and you're going to have to use what you chose for your data. So I'm going to use my numbers and explain the process, and just remember that you have to use the 20 numbers that you chose, okay? So it says use the data you collected from part 1 to complete this portion of the project. So if you came to Class Connect and you watched me work through the 9.01, or maybe you already just watched the help video, I used 20 lifespan numbers of different animals. So they're years that they would live to reach maturity. So my numbers went from 10 was my minimum number of years and 70 was my maximum. And then my average, my mean was 29.5 years. So I'm going to need to use my data that I collected and I found the mean from my 9.01 project. And then you're going to need to use your 20 numbers that you chose for your 9.01 project. Okay. We are going to use this formula. SD stands for standard deviation. That's what they're asking us to find here. This is a formula. This is the square root of the sum of the absolute value of X, which is your raw data point, minus mean, it's a symbol for mean, divided by N, which is the number of data that you have. And we're all going to have 20 because that's what it told us to choose. I don't think anybody's going to choose more than 20. If you chose more than 20, your N is going to be the number of data points that you chose. Okay, so SD stands for standard deviation. X is your value, each value. This is your value, each one of your 20 values. This is the value for mean. And then we're going to square that. Once we subtract, I'll show you how to do that. This symbol means add everything up. This is the summation symbol. And then N is going to be the number of data, which is 20. So step 1 says find the mean. Okay, we've already found the mean. I found my mean. Your mean's going to be different. My mean was 29.5. I did that in the 9.01 project. Step 2 is for each data point, find the square of the difference of its distance to the mean. So that means you're going to do your data point minus your mean, and then you're going to square that. And I'll show you what that looks like. Then you're going to sum them up. So you're going to add all those up. You're going to divide by the number of data points you have, which means you're going to divide by 20. And then you're going to take the square root. Okay, so here are my data points. I think I have it listed in a chart. Yeah, here we go. Okay, so here are the data points that I chose. These are lifespans of the animals that I searched up on the internet. So for each one of these, you're going to do the data point minus the mean, and your 29.5 is going to be different, and your 10 is going to be different, and then you're going to square that. And then you're going to do 14 minus 29.5, and then you're going to square that. You're going to do 15 minus 29.5, and then you're going to square that. And then there's no reason to do it again for all the 15s. So just do that once, and I'll show you what to do. Move down to 20, subtract your mean, square that. Again, no reason to do that for the next two 20s. Move down to 23, minus your mean, subtract and square that. And then 25 is different. So you'll do 25 minus your mean, or whatever your number is, minus your mean. 28 minus your mean, square that. 30 minus your mean, square that. 34 minus your mean, square that. I'm going to come back when I grab my calculator just a minute. And then 45 minus your mean, square that. 50 minus your mean, square that. No reason to do it for the other two 50s. And then 70 minus your mean, and square that. So I'm going to change colors here. And we will go ahead and calculate those. So make sure that you do 10 minus the 29.5 and then get that number and then square it. So when I type that into my calculator, I get 380. I'm just going to write these in pink. I get 380.25. And by the way, I think 9.02 is the hardest out of 901, 902, 903, and 904. So don't think, oh, 902 was so hard, I'm not going to try 903 or 904, because for some of you, both of those are going to be bonuses, depending on whether you're in regular algebra or honors algebra 2. So 903 and 904's assignments are easier than 902. I think 902 is the hardest one. And then we're going to do 14 minus 29.5. And we're going to square that. That's going to give us 240.25. And then I'm going to do 15 minus 29.5. And then I'm going to square that. And that's going to give me 210.25. And then that'll be the same number for all your 15s. For all of my 15s. Your numbers are going to be different. I'm just showing you how to do this with my data. Then I'm going to move to 20. I'm going to do 20 minus 29.5 and square that. That's going to give me 90.25. And then I can use 90.25 for my other two 20s. And I'm going to move to 23. And I'm going to do 23 minus 29.5. Take that number and square it. And by the way, all these numbers are going to be positive. Even if you get a negative number here, when you square a negative, so you'll need to put this in parentheses. So you can do parentheses 23, subtract 29.5, parentheses squared. If you don't put this in parentheses, you could get a negative number, and we don't ever get a negative number when we square something. So when we do 23 minus 29.5, and then we take that number and multiply it times itself, we get 42.25. When we do 25 minus 29.5 and we square that, we get 20.25. When we do 28 minus 29.5 and we square that, we get 2.25. When we do 30 minus 29.5 and we square that, we get 0.25. We do 34 minus the mean and we square that, we get 20.25. When we do 40 minus the mean and we square that, we get 110.25. When we do 45 minus the mean and square that, we get 240.25. When we do 50 minus 29.5 or 29.5 and we square that, we get 420.25. And then I'll use this for all my 50s. And then when we do 70, that was our max, minus the mean, and we square that, we get a really big number, 1640.25. So to me, this is the longest problem out of all 4 of the stats projects. So you're going to take each one of your data points. Remember, it's going to be your data minus your mean, and then you're going to square that. And I would suggest that you use your calculator and you literally do parentheses, your data point, minus your mean, parentheses, and then hit the square button. That's going to give you the accurate number every single time. Okay, so for each data point, find the square of its distance to the mean. So that's what we just did. That's step 2. Okay, check, we did that. Step 3, sum the values from step 2. So I'm going to add all of these up. Okay, I've already done that. So I am going to write total for my values. Yours is going to be different, but you're going to add up all these numbers, all these pink numbers. And I got 5,069. So I did that part. We're still working on the formula. Divide by the number of data. So we're going to divide by 20, the number of numbers that you have. And then once we do that, we're going to take the square root. So 5,069 divided by 20. And then I'm going to take my square root. Let me grab my calculator here. 5,069 divided by 20 is 253.45. And then we take the square root of that. Someone has taken my calculator, so I'm using my phone, which I don't like to use for a calculator, but I don't know who would do that. But the square root of 253.45, I mean, I could have misplaced it, but I don't usually do that. I'm getting 15.9, so I'm going to go ahead and round it up to 16. Go ahead and make your standard deviation a whole number. Okay, that's just going to be easier. So just round your standard deviation. So again, I did all this stuff because I'm working this formula. And we just did it by steps. Okay, so find the mean. You did that in project 9 point, your stats project 9.01. Step number 2 is this long part. This is where you take each data, you subtract your mean, you put that in parentheses, and then you square it. So you get a number. So you'll get 20 more numbers. That's your data minus your mean in parentheses squared. That's going to be this number. Then we can keep following the directions. And we added them all up. That gave me the 5,069. We divided by the number of data points, which is the 20. That gave us the 253.45. And then our last step was to take the square root. So for number 1, it says find the standard deviation. So we're going to say our standard deviation is 16. Just showing you the process there. So remember, your standard deviation is if we have that bell curve and we have the mean in the middle, then we add 16 to get to standard deviation, 1. We add 16 again to get to 2 and so forth. So that standard deviation is really important. So that's what you're doing for number 1. That's number 1. All right, number 2 says create a frequency distribution table for your data. So frequency distribution, that's something that we've studied this semester when we've been studying about statistics. For an example of how to do that, there is a link added into your assignment, but I'll show you how to do this. You can probably do this without even looking at the link. So again, here are my numbers from the smallest to the largest. So when we do a frequency table, any number that's repeated, we're not going to repeat. So I only have 110. So I put 110. I only have 114. I have 4 15s. So I don't do 15, 15, 15, 15. I just put 15, and I say I have 4 of them. That simplifies our table. Then we have our next number is 20. We have 3 of those. I have 123. I have 125. I have 128. I have 130. I have 134. I have 140. I have 145. I have 3 50s. And maybe I needed one more box. And I had 170. So that should have gone out. So let's look at this. 10, 14, 15. Let me just double check. 20, 23, 25, 28, 30, 34, 40, 45, 50, 70. And then my frequencies are 1, 1, 4, 3, and then a bunch of 1s, and then 3 and 1. And to double check these frequencies should add up to be 20 numbers. So I want to add them. 1 plus 1 is 2. 2 plus 4 is 6. 6 plus 3 is 9. 10, 11, 12, 13, 14, 15, 16. Plus 3 is 19. 19 plus 1 is 20. All right, so there's your frequency table. So again, this link is just to show you how to do a frequency table. You don't need any information from there, but I just added that in just to be helpful. All right, let's look at number 3. Number 3 is asking you to create a probability distribution table. So this time we've got to do the probability. So we need our numbers again, okay? And if they're repeated, we don't repeat them. So we're going to do 10 and then 14. 15 is repeated, 20 is repeated, 23, 25, 28, 30, 34, 40, 45, 50 is repeated, and then we needed one more slot for 70. So to find, let's see if it tells you anything about decimals. So you can use fractions or decimals here. It says create a probability distribution table for an example of how to do this. This is just a link with an example. You don't need any information from that link. But when we're doing probability, we're doing how many tens out of the total. So there's 1 10 out of a total of 20. There's 114 out of a total of 20. So you can leave your fraction. If you want to write these as a decimal, I'll show you how to do that. We'll just do fractions first. There are 1, 2, 3, 4 15s. So you would do 4 out of 20, and then that would reduce to be 1/5. You would need to reduce if your fraction reduces. There are 3 20s out of a total of 20 numbers. That does not reduce. There's 1 out of 20, 23, 1 out of 20, 25, 1 out of 20, 28, 1 out of 20, 30, 1 out of 20, 34, 1 out of 20, 40, 1 out of 20, 45. There are 3 50s, and there is 1 out of 20, 70. So you could leave your probability just like that. Okay, or you could do 1 divided by 20, and you could write your probabilities as decimals. So I will leave it up to you. It does not say anything specific in the directions, whether you need a fraction or a decimal. So just to show you, 1 divided by 20 is 0.05. So I have 0.05 for here. 4 divided by 20 is 0.2. 3 divided by 20 is 0.15. 1 divided by 20 is 0.05, 0.05, 0.05. You don't have to do the fraction and the decimal. You can choose whether you want to do the probability as a fraction or a decimal. I'm going to share one more thing, and then I'm going to move to the next problem. We already did 3. That's 0.15, and 1 is 0.05. You can add up all of your fractions, and they should add up to be 1. So 1 over 20 plus 1 over 20 is 2 20ths. And then that's 6 20ths, 9 20ths, 10 20ths, 11, 12, 13, 14, 15, 16, 19 20ths, 20 20ths. That adds up to be the whole number 1. That's just a way for you to check your probabilities. All your probabilities should add up to be 1. And then if you add up all these decimals in pink, they also add up to be 1. So you can do fractions or decimals here. Totally up to you. That's number 3. And number 4 is going to give you a picture of a bell curve. And it's going to say label the distribution curve with the mean. So your mean is going to be different than mine. My mean was 29.5. I found this out in the 9.01 project. And then you're going to do 6 standard deviations. That's going to be 3 to the right and 3 to the left. So remember, I found out in number 1 of this project that my standard deviation was 16. Yours is going to be different. And so as we move to the right, we're going to add 16, add 16, add 16. So 29.5 plus 16 is 45.5. 45.5 plus 16 is 61.5. And 61.5 plus 16 is 77.5. As we go to the left, we're going to subtract 16. So 29.5 minus 16 is 13.5. 13.5 minus 16 is negative 2.5, which really didn't make sense. We're talking about years, but you need to just follow the directions here. And then negative 2.5 minus 16 is negative 18.5. And these all represent years. Because remember, we're talking about lifespan of my animals. It can't be negative years, so I know that doesn't make sense, but you do need to label 6 standard deviations. So it's going to be 3 to the right. So this one, this one, this one. You also need to label your mean. Your mean's always in the middle. And then you need to label the 3 standard deviations to the left. All right, that is Stats Project 9.02. Remember, you're going to have a different mean because you had 20 different numbers than I chose. And you're going to have a different standard deviation. All right, good luck.